Calculus, Unit 3, Day 23 notes. The objectives, two of them, analytically determine the derivative of an exponential functions whose bases are e and natural log functions. And then we're going to numerically determine and interpret the value of the derivative of a function using the graphing calculator. Okay, so as we look at another rule of differentiation, so finding the derivative of the natural exponential and logarithmic functions. So first, the differentiation rule for natural exponential functions. So derivative with respect to x of e of f of x is equal to e to the f of x power times f prime of x. And I'm going to write this another way also. So another way, if I take the derivative with respect to x of e to the u, that's going to be e to the u times u prime. So whatever that exponent is, we have to take the derivative at the end. So kind of like the chain rule. All right, let's try some of these. And you can stay 1 or 2 steps ahead of me if you want, and then check them. Okay, so for this one, it's you take just leave e to whatever power it is, so e to the sine x times the derivative of what the exponent was, and derivative of sine x is cosine x. So that's our answer, and then we just rewrite it so that it's cosine x times e to the sine x. Again, just change the order that you're multiplying. All right, let's try the second. And we get e to the 2x plus 3 times the derivative of the exponent, which derivative of 2x plus 3 is just 2. Then we just rewrite it, so it's 2 times e to the 2x plus 3. All right, when you guys try the next two, and then we'll check. All right, looking at the third one, it's what was there, 3e to the 2x times the derivative of the exponent times 2, and then I just simplify 2 times 3 is 6, e to the 2x. Now, the question might be asked, well, how come we don't have to do the product rule? And if you do exactly what we just did there. So that's the first times the derivative of the second, and then if I did plus the second, so e to the 2x, and I'm just treating that the answer was there, times the derivative of the first, which was, so if you had it as 3 times 3 the first term and e to the 2x second, derivative of 3 is 0, and everything would have gone to 0. So we end up, if your constant is one of the terms, the first term or the second term, then that whole part's going to go to 0. Well, over on this fourth one, we do need to do the product rule. So I'm going to do the first times derivative of the second. So here's where we use our new rule. E to the 3x times 3 plus the second times the derivative of the first, and the derivative of 2x plus 3 is just 2. So now let's first go and distribute this. So we have this 3e to the 3x that we have to distribute to each of these terms. 3e to the 3x times 2x is 6x e to the 3x, and then 3e to the 3x times 3 is 9e to the 3x. Now I look and I see that I can combine some like terms, and I'm actually going to put the ones that don't have the x in there first. So 9e to the 3x plus 2e to the 3x is 11e to the 3x plus, and then 6x e to the 3x. And that's my final answer. Those cannot be combined. All right, let's do the last two, and that'll be it for video one. Actually, there's 3 of them. Let's do all 3 of these, and we'll be done with video 1. So here, I'm going to have to use the product rule again. So it's going to be the derivative of the first. And notice I change which way I do it. It doesn't matter. Just whatever way you pick, stick with that way. So derivative of the first times the second plus the first times the derivative of the second. So e to the 2x times 2. Now let's simplify these. And when I simplify, I get 2x e to the 2x plus 2x squared e to the 2x, and that's my final answer. So those are not like terms, and I don't want to, I could factor out an e to the 2x, but that's not going to be simplified. So we'll leave it like this. All right, next one, and to do this, we're going to rewrite it with a rational exponent. So let's rewrite it as f of x equals e to the 2x minus 6 all to the 1/2 power, and we're going to have to use the chain rule. And as I'm starting to go through, so the chain rule says bring the power out front, and I'm doing this, cruising right along, so let me finish the way I'm doing it, and then I'm going to show you a shortcut that I didn't realize till I'm halfway through the problem. So bring the 1/2 power out times what's inside, leave that the same, subtract by 1, times the derivative of what was inside. So that's going to be e to the 2x minus 6, and then I'm going to multiply by the derivative of that power, which will be 2. Now, I can go and simplify that, like the 2 and the 1/2 are going to cancel out, and we're going to get some stuff. But what we taught when we have raising a power to a power, what do? Hey, I multiply those. So, and I'm going to go back and end up starting this all over again. So when I have e to the 2x minus 6 all to the 1/2 power, hey, raise a power to a power, that multiplying 1/2 times 2 is just 1. Negative 6 times 1/2 is negative 3. So now I have to do the derivative of that, and that's much easier than simplifying all this. All right, and again, just a reminder, x to the 4th all to the 7th power, raise a power to a power, you multiply exponents. That was x to the 28th. So let's start this over again, and it's much easier. Because again, we get the same answer, but let's simplify it like this. All right, much easier now. So now when I take the derivative, it's e to the x minus 3 times the derivative of the exponent, which is just 1. So my final answer is just e to the x minus 3. And that's it. All right, let's go to the last one. All right, last one, we need to use the quotient rule. Hody high minus heighty ho over ho ho. So let's do it. So hopefully after that first step, this is what you get. Now we're going to simplify it. And it should be here. And hopefully you notice that in every term, I have a 3x that I could factor out. So I'm going to do that right now. And now we can cancel out those 3's. Now, I would let you leave it like that. But you could also see that we have an e to the 5x. Of course, I told you up above not to do that, but we could factor out the e to the 5x and be left with 5x minus 2 all over 3x cubed. So I would accept either one of those. Okay? All right, that's video 1.